Hi all. Today I going to discuss the basic experiments. That is a basic we used in our physics lab. So first one is screw gauge. So all of you know this we used in our school days. So it is a precision measuring instrument used to measure a very small distance with high accuracy. That measurement in the around of 10 to the power, that is millimeter, 10 to the power of minus 3 millimeter, that is a 10 to the power of minus 3 meter. So it is commonly used in engineering, manufacturing and scientific application wherever the required precious measurement is required, we use the screw gauge. So this screw gauge consists of U-shaped frame with a thimble, that is this is called a thimble, attached to one end and the screw mechanism on the other end. The screw has a precision thread which is a known pitch. Here we measure that least count in the pitch and it is attached to the spindle. The spindle moves when the screw is rotated by turning the timbers. So to measure a distance using a screw gauge, the object is placed between the stud and the measuring face of the spindle. The thimble is then rotated, causing the screw to move to advance towards the object. Then reading is taken by observing the aligned marked on the thimble, that is on the sleeves. Here this is the main scale, this is circular scale. So we keep here any object, for example your hair or thin wire or something. First we rotate the screw, tighten, then we have a sound, that is an that arrangement we have to hear up to, we have tied this thread up to that sound. After that we have noted this main scale reading and adjacently here this is a head scale division. So by using these two scale division one can able to calculate this value. So the accuracy of screw gauge is dependent on the design and quality of the measuring. Typically what I say that is a millimeter, 0.1 millimeter or even sometimes smaller than this. We have plenty of screw gauge available, that is the types exam, that is a lot of dimension, that is inner dimension or outer dimension whatever have to measure. Here this screw gauge is commonly used in industries, laboratories, where we need the fine adjustment. So these all about screw gauge. We use the screw gauge. The next one is all we know, vernier calipers. So it is a linear dimension. Here also we measure the dimension, that is distance or diameter with high accuracy in the range of 10 to the power minus 2 meter. So it consists of a main scale with a sliding vernier scale which allow for precise reading of small distance. Vernier calipers are widely used in industries, laboratories and workshops. So here coming to the part, we have a main scale. Sometimes in millimeter or inches we fix that main scale. Then vernier scale. This scale is called a vernier scale, small vernier scale. So it is a secondary scale. It is along with the main scale. So from this we have to coincide. We measure the coincidence. Then we have a jaws. That's these jaws. Upper jaws, the outside measuring jaw, we called as a inside measuring jaw. These are the jaws. So in between this, our what object we have to measure, we keep that object within between these jaws and tighten by this sliding screw. Then we have to see the what is the main scale reading and what is the vernier scale reading. Accordingly we can know that, know the reading. So the operation is that is we have to tighten the sliding screw. So application where we apply this dimensional measurement, wherever the dimensional measurement we can apply this. Both internal and external dimension, that is we have to measure any type of dimension. Depth measurement, that is depth of sometimes we use to measure the depth of holes, slots or something. And it is an quality control process because some type of manufacturing component meet to required specification. We have to correctly we have some specification, that is industry, manufacturing industry, engineering or metalworking. So in that area we have used this vernier calipers. Next one is meter. Here I show meter and voltmeter. So meters, in every physics lab we have a plenty of meters, ammeters, voltmeter, galvanometer. So through mainly we use these meters. What is ammeter? Ammeter is used to measure electrical current flowing through a circuit or component. It is usually connected in series with the component that is being measured, that is the series connection. So ammeter is commonly used for current measurement, wherever the current, that is an amount of current flowing through the resistors or capacitors or inductors or any other components. It is essential tool for understanding and analyzing the behavior of electrical current. And wherever the circuit testing and troubleshooting, we use this ammeter. For electrical safety, sometimes there are situations where the current limited need to be monitored and maintained. So in that, mostly we use electrical department, electrical equipment, power lines or high current application, we use this ammeters. Next one is a voltmeter. We frequently use this voltmeter, that is we have a range 2 to 5 volt, 0.2 to point. Accordingly we have a plenty of range in voltmeter. So it is in the instrument used to measure electrical potential or voltage, whatever. It is typically connected in parallel to the component or circuit being measured. Some type of application is electrical circuit. That is a voltmeter are used to measure voltage across the components such as resistors or whatever the capacitor, batteries. We have to measure, usually first we measure the voltage, what voltage they that circuit, if it is circuit is closed or opened. So it helps to determine the potential difference, that is monitoring the voltage level in the circuit. Some type of power systems, that is transmission line, networking line, electrical panel, we use this voltmeter. Sometimes voltage we have to measure the or monitoring the voltage stability and ensuring the proper functioning of the power functions. So all type of electrical and electronic equipment, we use this voltmeter. Next one is galvanometer. I not show in this figure, but galvanometer is also one important meter. So that is used to detect and measure a very small current. So by the word galvanometer, we always remember that null deflection. So in galvanometer, we not measure any, but in the middle we have 0, left hand side, right hand side. So if there is a null deflection, it seems that the circuit is in a balancing conditions. So it consists of a coil of wire suspended in magnetic field with a pointer needle attached to this. So application of galvanometer, we measure a weak current wherever the current, it is a whatever the area, that is meter movement, that is instruments such as voltmeter, that is calibration of voltmeter, ammeter, we use the galvanometer, that is the main source. Feedback control systems, type of sensors, we have to measure a very small deviation of current and voltage, we use a galvanometer. So sometimes control and regulate various processor, we use this galvanometer. Next one is traveling microscope. You see this image in our physics lab, we have used this type of traveling microscope. It offers a very high magnification and allow for precise measurement of small distance or dimension, whatever. So it is commonly used to determine the size of small object, that is a traveling microscope. So what actually we use, that we have to use in a Young's modulus, cantilever, this type of experiment, we use this traveling microscope. So first we have a screw, here we have a lens, here eyepiece. So by using this, we have to measure, we have to Newton's ring, air gauge or whatever the optical devices instrument, we have measuring this by using this traveling microscope, such as thin film or micro slides, thin films like air gauge, Newton's rings, that all type of experiment done by this traveling microscope. Thank you.